Okay, so today we're going to talk about the properties of quadratic functions in standard form. So we've been looking at them in vertex form, so now we're going to look at them in standard form. So when you transform the quadratic functions in the previous lesson, we saw that reflecting the parent function across the y-axis resulted in the same thing. So f of x equals x squared, g of x equals negative x. That quantity squared equals x squared. Which means then that that line through the vertex of the parabola is called the axis of symmetry. So when we take vertex form here, then a times quantity x minus h squared plus k, the axis of symmetry is actually the line x equals h. So it's not just h, it's the line x equals h. So if we know what the vertex is of the quadratic function, then we can find the axis of symmetry, and it is a line. Sometimes they call it the line of symmetry. So we want to identify the axis of symmetry here. And so the axis of symmetry would just be the line x equals negative 5, the value of h. So since h is negative 5, x equals negative 5 would be the axis of symmetry. Alright, so now we're going to talk about standard form of a quadratic function. Standard form is here, f of x equals ax squared plus bx plus c. Where if I took vertex form and transformed it and multiplied it out, then I would get the standard form, where my a's are still the same. B would be equal to negative 2 times a times h, and c would be ah squared plus k. So if we did the vertex form, so this is the same as a times x minus h squared plus k. The only thing is that when I multiply this out, so I FOIL the x minus h squared, and so I get this. So now, A is A. Tells us whether it opens up, opens down. If it's positive, it opens up. If it's negative, it opens down. B helps us to find the axis of symmetry and the x-coordinate for the vertex. So it says solving for h with this equation here gives us negative b over 2a. So that means that h is equal to negative b over 2a. Since x equals h for the axis of symmetry or the vertex, the x-coordinate of the vertex, then we can find the axis of symmetry and x for the vertex by using negative b over 2a. And then c is just the constant, which is the y-intercept. So that talks about all of that here. If a is greater than 0, opens up. Less than 0, opens down. The axis of symmetry is the line x equals negative b over 2a. The vertex, the x-coordinate, is the same as here, negative b over 2a. To find the y-coordinate for the vertex, I take the x-coordinate and I plug it in to my equation and find the y-coordinate. Alright, so let's take a look at one example. I think we've got enough time for it. It says 2x squared minus 4x plus 5. So, we want to determine whether it opens up or down, and this opens, so letter A, it opens up because A equals 2, and that is greater than 0. The axis of symmetry, x equals negative b over 2a. So b is negative 4, so I have the opposite of negative 4 over 2 times 2. So x equals, opposite of negative 4 is 4 over 4 equals 1. So the axis of symmetry is x equals 1. The vertex, okay, letter C. To find the vertex, here's the x value for the vertex. Right, we have 1 and some other number. To find that other number, I just take the number 1 here and put it in for x. So I'm talking about now finding the value of k. Remember the vertex is hk. H was 1, the axis of symmetry. So I need to find k. So we do 2 times 1 squared minus 4 times 1 plus 5. So we get 2 minus 4 plus 5. So 7 minus 4 is 3. So my vertex is the point 1, 3. The y-intercept is a number by itself, so that's 5. Right? And then they want us to graph the function. Well, graphing the function is really pretty simple because now I know the vertex, I know the y-intercept, and if I know the vertex and the y-intercept in the axis of symmetry, I can graph it. So let's go ahead and graph it here. The vertex is the point 1, 3. So I go to 1, 3, plot my point. The y-intercept is 5, so I plot that point on the y-axis. Now since I have the axis of symmetry here at x equals 1, and since a parabola is symmetrical, that means that I'm going to have this point here also is going to be on the graph. So then to draw my graph then, we just use those 2 points and draw my graph. So once I find the axis of symmetry and the vertex, y-intercept, I can draw my graph from those things.